All right, hello everyone. We're going to be going over section 6.3, which is on factoring trinomials by grouping. So we just have one objective today. We want to factor trinomials by grouping when the coefficient of the second degree term is not 1. So this is going to be grouping with polynomials, trinomials, anything along those lines, with your second degree term, which is most often your first term. In that case, so normally the x squared term. So that term where the coefficient is not 1. So we now want to extend our work to factor a trinomial, such as something like 2x squared plus 7x plus 6, where the coefficient of x squared is not going to be 1. So we'll do everything the same way as we did in our previous sections. We're just really applying a lot of things that we've learned, and now we're focusing on some other things. So as our first example, we want to factor the trinomial 6r squared plus r minus 1. So the way that we're going to go about this problem is that we still need to find two integers that will multiply to -1, but kind of have a different factor here. So we need to find two integers whose product of and the product is going to be the coefficient times our last term. So we're focusing on the product 6 times -1, which is equal to -6. So we're finding two integers whose product is now equal to -6. This will just help us find these values. And whose sum is +1. And this +1 is from 1r, not our final value. So these integers, using everything that we've learned so far, we want to find two integers that are going to multiply to -6. This can only be -2 and 3 or 2 and -3. They need to add to +1, so this means it has to be -2 and +3. So these integers are -2 and +3. Then we can rewrite our expression as we're basically rewriting our center term. So we're rewriting r, and we're now writing it as 6r squared minus 2r plus 3r minus 1. So this is now how we're rewriting our expression. And when we rewrite our expression this way, we want to now factor by grouping. So now factor by grouping. We are just going to put parentheses around our first two terms and our last two terms. So we're going to get 6r squared minus 2r plus 3r minus 1. Now 3r minus 1 doesn't simplify, but 6r squared minus 2r can. 6r squared minus 2r, we can factor out a 2r in both cases. And when we do, we're going to get 3r minus 1, which is what we have in our other term. So these are the same. Our coefficient in front of 3r minus 1 is technically 1. So when we factor out 3r minus 1 of our equation, we're left with 2r plus 1. And this would be the factorization of 6r squared plus r minus 1. Another way that you could think of it is you can think about combinations of numbers that multiply out to be -1, but also variables that have coefficients that would multiply to be +6. So you can think about it in that sense, or you could write it this way. So we found the factorization of our polynomial, and now we just want to multiply and check, make sure these are right. So we're going to check 3r minus 1 times 2r plus 1. We're going to FOIL, so we get 3r times 2r plus 3r times 1 plus -1 times 2r plus -1 times 1. And this is going to give us 6r squared plus 3r minus 2r minus 1, which we simplify to 6r squared plus r minus 1. So our factorization is correct. So our answer there for 6x squared plus r minus 1 was 3r minus 1 times 2r plus 1. And then we can do another problem. So same thing, example 2, we want to factor 12x to the power of 4 plus 12x cubed minus 9x squared. So this is another problem that we can definitely factor out a greatest common factor before we even have to find our factorization of our trinomial by grouping in this case. So we can factor out our greatest common factor first. So for factoring out our greatest common factor first, let's kind of expand each one of our terms. We see that there is at least an x squared in each one of our terms, so we can keep that in mind when we factor. So 12x to the power of 4, the prime factorization of 12 is going to be 2 times 6, which is the same as 2 times 2 times 3. Then we have times x squared times x squared. Then we have 12x cubed. So same factoring since it's 12, 2 times 2 times 3 times x squared. And lastly, minus 9x squared. So we'll say minus 3 times 3 times x squared. And now we can identify the terms that are in each factorization. We can say that there is a 3 in each factorization, as well as an x squared. So this means, wrong thing. Our greatest common factor is 3 times x squared, which is just 3x squared. So rewriting our equation, we get 3x squared times, we're going to have 4x squared plus 4x minus 3. So this is our new equation now. And now we can focus on our trinomial. Focus. So you think about what numbers are going to multiply to be -3 as our second terms in our binomial, and then numbers that will multiply to be 4, or 4x squared technically when we multiply our first terms in our binomial. Or we can use the same method we used in our last problem. So we need two integers. That multiply to our last term times our first coefficient. So multiply to -3 times 4, which is -12. And add to 4. And this is, remember, found from our middle term, which was 4x. So from 4x. So numbers that multiply to negative 12 and add to 4, these are going to be two numbers with opposite signs. So numbers that multiply to negative 12 would be variations of 12 and 1, variations of 2 and 6, and variations of 3 and 4. Since our middle number is a positive 4, the only numbers that would make sense in this case would be positive 6 and negative 2. So our integers are 6 and negative 2. You can always write out your tables if you still need help kind of working through this idea, but if you kind of get the hang of it, you can go about it this way. So our integers that we're working with are going to be 6 and negative 2. So now we're going to rewrite, and we can rewrite our whole expression here. We say 3x squared times 4x squared plus 4x minus 3. This can be rewritten as 3x squared times 4x squared plus 6x minus 2x minus 3. And we're focusing on our trinomial in this case, so we're just going to kind of mark that off. So we can go ahead and we can group our terms. We'll group our first terms and our last terms. And when we do, we'll get 4x squared minus 6x, I'm sorry, plus 6x. And now we can write minus, because we have a negative 2x, negative 3. So let's write minus 2x plus 3. Because when we distribute that negative, we'll end up with a negative 2x minus 3. And now we remember we want to find the greatest common factor. So in 2x plus 3, there is no greatest common factor. But in 4x squared plus 6x, we can find a greatest common factor. And in this case, 4x squared plus 6x, our answer is going to be 2x. So we'll have 2x times 2x plus 3. And now what we see here is that we have minus 1 times 2x plus 3. Now we have 2x plus 3 in both cases. And we can say 2x plus 3 times whatever was left over, which was 2x minus 1. So this means that our first answer, our original equation that we had, which was 12x to the power of 4 plus 12x to the power of 3 minus 9x squared, this is equal to 3x squared times 2x plus 3 times 2x minus 1. This would be the factorization of our trinomial using grouping. And now we just want to check and make sure that this is correct. So we want to multiply our binomials together first, where we had 3x squared times 2x plus 3 times 2x minus 1. This is going to turn into, and let's actually take it down here. This will be 3x squared times, and now we're going to FOIL out our terms here. So we have 2x times 2x plus 2x times negative 1 plus 3 times 2x plus 3 times negative 1. So simplifying, 2x times 2x is going to be 4x squared minus 2x plus 6x minus 3, which we can simplify further, get 3x squared times 4x squared plus 4x minus 3. Now we just distribute our 3x squared. So we get 3x squared times 4x squared plus 3x squared times 4x plus 3x squared times -3. And simplifying this expression, 3 times 4 is 12. X to the 4th plus 3 times 4, which is 12. X to the power of 3 plus 3 times -3 is -9x squared. So our answer of 3x squared times 2x plus 3 times 2x minus 1 is correct. So all right, that finishes up our section 6.3, and I will see you all again in our next sections.